Hi everyone, I'm Shahan. This video is about showing some very basic FHIR concepts with simple JSON and XML examples. So I assume that you have some familiarity with what JSON and XML is. If you're not, those are a couple links on the slide to have a good starting place. The examples are, like I said, they're simplistic. They're not real FHIR. They're just to review JSON XML and then give an analogy of FHIR concepts. We'll talk about what is an element path. That's a very important thing in FHIR, and defining and constraining a path is also another important part of working with FHIR profiles. And again, like I said, this is just introducing simple ideas. Okay, so let's take a look at some JSON first. So in a later video, I'll explain how to find these files. I have a GitHub repository along with this channel that I'm still setting up. Okay, so this file here is a JSON file. Ignore some of the first few lines. If you're familiar with JSON, you'll recognize this. The JSON object starts from that bracket and ends in this bracket. A object is a set of unique fields. Each field has a name, and the field holds a value. So for example, here we have a field and it holds a value. A field can also hold an array. So an array starts with a bracket, and you could have multiple values in an array separated by a comma. So this field has multiple values. And the array has an order, but the order of an array is separate from whether or not a FHIR field has an order. That's a separate thing. We'll get into it later. But this, as a JSON field, has an order because it's an ordered array. A field in JSON could also have an object. So an object starts with a curly brace instead of a straight bracket. And inside the object, you could have further nested fields, whatever you like. This field is in this object and is completely separate from the outer fields in the outer object. Now, what you see here, this is not valid JSON here, but I just want to show an idea. If you have a field in JSON, and in this case, you see spaces in the name of the field, that's allowed in JSON, but you wouldn't really name fields this way. So if you have a field and you want to both have a simple value on it, but you also want to have nested values on that same field, you cannot do something like this. You cannot put the simple literal value like you did up here and then start an object and put nested things. And this is an important feature that is not available in JSON, but is needed in FHIR, and I'll show it through XML, how this works in XML in a slightly different way. What is done in FHIR to accommodate this scenario, a nested content within a field that has simple value, FHIR takes this approach. It will create a field name according to your profile or the resource you're working with. I'm referring to FHIR a lot, and I haven't introduced it yet. I understand that, but hopefully you're getting the sense of what I'm trying to explain here. So the field name has the simple value, and then in FHIR JSON, they would the tools that generate JSON will then prepend a underscore to the same field name and attach an object to that. And then within that object, you will have your nested values. So in FHIR, these are technically the same field, but in JSON, they're represented this way. Okay, so this is how a JSON object works, how a field holds values. And now if we come over here and look at XML, it's sort of similar, but XML is a little bit richer in terms of what it could do. So if we look at this set, this content, this is equivalent to the JSON object. It's XML, just like JSON, starts with an outer wrapper. It's an element, a tag. It's not a simple curly brace like you see in JSON. This could be named whatever you like. All these could be named whatever you like. So, and within this outer wrapper, you could have a field named whatever you want. It's named field in this case, and it's holding a value. The value is between these two tags, XML tags, so the opening tag and the closing tag. The closing tag starts with a /. But also XML has this idea of an attribute. So a tag, a element or a tag, can have a value within the two tags, but also it has attributes. A tag itself could have an attribute. So this is some attribute name. It could be whatever you want. And it can hold a value, and it could have multiple attributes. So you could also capture the same value on the same tag through an attribute like this. And then you would leave it empty in between here, and you would close it, or you could do it the shorter way, and this is what you would see usually in JSON XML. I mean, sorry, in FHIR XML. You'll see the value of a field held in an attribute, and then the tag is closed without having to repeat the full closing tag. Okay, so this means a field name, whatever it is, this could be whatever you want, can hold a value with the attribute value. And this is how, again, this is how FHIR does it. There's an attribute called value that holds the value. And it holds whatever it is, but then you could then nest content within it. Unlike in JSON, you have to have this sort of surrogate property that is the same name prefixed with underscore. In XML, it's easier to do. If there are nested elements, this is how you would do it. If there's no nested element, you would usually see it. You'll see it like this. You'll see the value attribute, and it's holding the value, and then it's closed. If you've seen HTML, you know that XML also allows you to have the literal value within the tag. So this is the outer tag, and you could put in a value, literal value, and then you could start another nested tag within it. So it's sort of like mixed content. You have both your values and nested tags together. This doesn't work in FHIR, and it's usually a bad idea. It works in HTML because it's about presentation, not about data. Okay, so now that we have a little bit of orientation of JSON and XML, let's look at a simple JSON object that is meant to represent a patient. And this is where we're starting to try to kind of come up with some not real FHIR examples, but I want to start to show some FHIR concepts. So the first thing you notice in JSON, there is no way to give the outer object, this curly brace, there's no way to know what type of object it is. In XML, it's easy because you would put the name, for example, of the type. So in here, this tag, the opening tag for this patient, this is clearly a patient because it's named patient. The outer wrapper is named patient. Since JSON doesn't do that, FHIR's approach for capturing the type of a JSON object is with resource type. So there is a FHIR JSON property called resource type. It will hold the type of the resource. So this word patient here is the same as this patient here. Okay. And there is also usually an ID associated with FHIR objects. And the field for that is called ID. And in XML, it's held as an attribute on the element that the ID is an identifier of. So ID right here is captured on an element. Okay. So now let's say you want to capture a name, the patient's name in FHIR. There are multiple ways of doing it, and I'm not showing the FHIR way. I just want to show options here. So you could have a simple field called name, and you have the full name. And it would work this way in JSON, like you see right here. Or it could work this way. So here I'm trying to actually show multiple things at the same time, which is a bad idea. So you have the field name, and you could capture within it the simple name, ignore this nested stuff. You could capture it that way, or you could break it down into attributes on the name, so first name and last name. You could do it that way, or you could have dedicated nested elements under name. So we had name and then first name, and then you put the first name and so forth. And I should also show the equivalent of this in FHIR. So the other way that FHIR would really do it is value equals John. I should have noticed that I'm not ready here for you guys. Okay, so this is really how FHIR will do it. It would have a outer wrapper name, and then we'll have within it the first name, and then the value, and the holds the value. And same thing would happen for the last name. Okay. So, and then you could repeat names as many names as you want. So this is one name. You could add another name. What you see here in some XML schemas, they like to wrap repeated elements. So if you're repeating name, sometimes it's wrapped with this plural version of the property names. You would not see this in FHIR. In FHIR, if you need to repeat it, you repeat it. You'll just have a flat list of repeated names. Okay, so you'll see the same thing over here on the JSON side. You have the simple full name. You'll have a name object broken down by first name and last name. And you could have a name array, which allows you to have multiple full names. Or you could have a name array of objects that break down the name into first name and last name. So if you want to allow multiple entries for name and you want them broken down by first and last name, you would have a field called name that has an array, and then you start creating one object per name, and you populate the first and the last name, and like that. And you could continue like that, create more of those. Okay, so I hope this is not too confusing. You have a patient, and it has a field called name, and under it, there's a field called first name. Okay. So the next thing here I want to show is the idea of a path within a JSON object. So this is the object that we are working with, okay? And we're going to look at this other object and see how this object really is talking about a specific point in this first object. So let's look at the path field first. So this is patient.nameObject.firstName. Okay, so this is talking about this object right here that is rooted at patient. Okay, just like it's rooted here in XML at patient. It's talking about that object, and it's talking about the field called name object, which is name object right here. It's under that. And then it's talking about first name. So it's talking about this. So this path right here is talking about a very specific field, this one right here, okay? This is a path to that field, to that element. And it's saying that what the type of that field up here is a string. So you'll see, because it has double quotes. In JSON, you could have things that are other than string. In a FHIR, there are many other types that are represented as string, but they're meant to be very specific FHIR types. But the idea is that this path is intended to hold a string, and it does indeed hold a string. It's not a number. It's not like a true, false, or something like that. And it's saying the minimal length of that string can be 0, and the maximum could be 100. So this means that at this path in this field, we'll have to have a string that could be anywhere from 0 to 100 characters long. So the idea of this object down here, okay, it's all about defining that one field, that one data element. It first has to refer to it by the path to know which one is being talked about, and then it could say different kind of definitions about it, or rules for that field to be valid. So this is what's called in FHIR, it's called an element definition. In FHIR, it's more complex, and we'll get to that. But the idea is this: you'll have to point at a path, and then you have to say things about what an instance of that field would hold. Okay, so let's pretend that we are first defining that field with this definition. So we said this object, patient, okay, and this resource, let's forget the resource type for now. Okay, so this is defining that field. Let's say someone else comes and wants to reuse your field definition. So you've created this initial definition and you put it out there, and someone else needs to use that, but they want to say that that the minimal length of a field, of a name, has to be, let's say, be, I don't know, 1 character at least, not blank. It cannot be blank. And the max is 50, okay? So how is this working? You'll notice this second definition here, okay? It is pointing at the same path as this first one. And it's not redefining the field arbitrarily. It's saying I'm based on the first name definition, which is this one, which means my definition first is this definition. It's based on that. So it takes everything that's in this definition and then possibly overrides some of it. So this type string right here is really redundant because it's not doing anything different than the base. So this could be removed. The minimum length and maximum length are different from the base definition. So this is the change from the base definition. Okay. Now a definition that is based on another one cannot change in any possible way. It has to be within the constraints of the first definition. So for example, a name of minimal length 1 character. So if a name just has an A in it, it's still a valid name according to the base definition because this one says its minimum is 0. So it's still an A by itself. It still passes this definition. A name less than 50 is a name less than 100. So you'll notice that the definition, the overriding definition, it allows less possible names. It doesn't allow names over 50, but the base one allows over 50. It doesn't allow names with 0 characters. The base one allows 0 characters. So this idea of basing your definition of elements on a base definition means that you are further constraining it. You cannot widen it. You cannot make it looser. It has to be more constrained. So this is also kind of another important part of FHIR when we get to it. This is usually referred to as profiling. This is one piece of profiling. There's more to it, but this is the idea. You imagine a data object that you want to create. You create a definition for each element in it. You give it a path. You're basically placing a field called first name within a field called name object within a data object that is of type patient. And you're further than defining that field. Someone else could take what you've said and refine it further. Okay, so I hope this idea of defining a field with a path and then coming later and overriding it is sort of clear. And on the right side, you'll see the same thing in XML. So patient first name definition, it's the same thing as this one. And again, we needed the resource type to clearly say that this outer bracket here is a definition, an element definition, first name definition. In XML, we could put it right up here. And then same thing, we put a path, we put a type, minimum length, maximum length. And then down here, we did the same thing. We said based on this one, and then just assign different values. Okay, like I said, I assumed some familiarity with JSON and XML. If you're not familiar with it, this might have been a little bit confusing. Please find something online to get familiar with it. And these examples, again, were very simplistic. They're not what you expect to see in a FHIR file. Okay, so we'll get to that in a follow-up video. So just remember the key pieces. JSON is a set of keys and values. You have objects, they have fields, which are the keys. They have to be unique. You cannot repeat the keys. If you need a field that has repeated values, you would do it with an array. So you'll have a field that holds an array, and then in the array, you have the values. You could have a nested structure or a tree structure with nesting objects in JSON. And remember, in JSON, the objects themselves don't have a name on them. So if you need, if the type of the object is needed, it's captured in a field. And the idea of a path, it translates a FHIR path when you see real FHIR paths. It translates to the same path translates to JSON and XML. When we talk about paths and we start working with them, they're not JSON or XML specific. They are kind of conceptual or logical paths, and there's a way to translate that specifically to how to navigate JSON or XML. But usually the tooling and the APIs we're working with will take care of all that. Okay, so for XML, I think the thing to keep in mind that elements can repeat at the same level. So it will look different in an XML file when we look at that stuff. Mixed content, which is where I showed where you could mix the string and the nested element, it doesn't work in FHIR, but FHIR takes the approach of attributes, and there's a dedicated attribute called value, which is meant to hold the value of the element, and then the nested elements can be added after that. Okay, here, if you're already familiar with JSON FHIR and this sounded too basic for you and you want to see the full FHIR specification about this, follow this first link. All FHIR pages that I'll be linking to follow this pattern, hl7.org/FHIR. So just put a /formats.html and you will see dedicated pages for JSON, XML, and the other data types that are available. The other formats are available in FHIR. This idea of an element definition that I really kind of very informally explained here, that this is a element definition and this is another element definition that's based on this element definition. This has dedicated pages in the FHIR specification to document this. The element definition, there's a type called element definition that you use to create the definitions of all the elements in what we call a data structure. So you would use element definitions within a structure to define a structure, and then you create an instance of the structure in JSON or XML, and the paths will work whether it's JSON or XML. We'll get into all this in a follow-up video. I just wanted to put pointers here. If you want to jump ahead, follow these pointers, read these pages, and the detailed description page, which is linked here. And again, the pattern here is / after the prefix, element definition.html and structure definition.html. Okay, that's it for this video, and I'm going to have another one to further go into more details. Please like and subscribe if you find these videos useful. It will encourage me to keep going, and leave a comment. Let me know what you're interested in next, and if there's anything I could do to improve the content or the quality of these videos. Also, at some point, check out some of these resources listed here. They're still work in progress, and I will have a follow-up video to describe them. Keep in mind that this content is for educational purposes. There are no guarantees of accuracy and completeness, and you should use at your own risk. You might be seeing a few YouTube cards on the screen. They are suggested next videos or related playlists.